Hello. Hi guys, good morning. Welcome back to a new video. In this video problem, minimize length of array using operations. So like it is a kind of a case kind of problem. Okay, you just have to figure out all the possible cases which could have been handled and you just have to handle that. The problem simply says that you are given an array nums containing positive integers. Again, the integers in the array all are positive. That is one thing we have to make sure. Okay, when this thing is done, what ultimately we have to do is we have to minimize the length of nums by performing the following operations on any number of times. What is operation is? Operation is that we have to choose two distinct indices. Okay, two indices I and j, and again there is no condition. Okay, I should be less than j, I should be more than j. No, I and j can be any two distinct elements or distinct indices of nums, and both should be positive. Again, both should be positive. But you will ask, Aryan, okay, it is given that it will always be positive, then why are they even referring to both should be positive? We will see why they're specifically referring both should be positive, because they can become zero. How? We will see. Next operation says that we will select those two I and j indices values, which is nums I and nums j, and I'll do a modulus operation such that whatsoever will come by this modulus operation at the end, I will push that element at the end of my nums, and I will delete both of these nums I and nums of j, and I'll keep on repeating until I should be getting the minimum length possible of nums. That is the operation which I wanted. Now with these kind of problems, no, always take the example as the reference and try. Don't look at this example. Always in such kind of problems, you have read what the condition is. Now from yourself, try to build the examples. This is same what I'll do. Okay, I have 1, 4, 3 and 1. I know that. Firstly, let's understand that why they have mentioned that both should be positive. Because if I do a 1 mod 1, or let's forget 1 mod 1, let's say if I do a 4 mod 1, so you will see it will come as a 0, right? Now if I do for sure both will delete and then 0 will come in. Now this actually makes sure, okay, 0 will come in. So I cannot do a modulo. I cannot do a 0 mod 3 or a 3 mod 0, which means I should be doing a modulus only with the positive value. So there is one thing we have got to know so far. Okay, if something comes as 0, we are done. I cannot use it any further, which means he will for sure contribute in our length. That is one thing which we have seen so far. Okay, now it's obvious. See, it's obvious that if I have two numbers, again, I have not even looked at the example which I am doing, but I just figured out, okay, I just want to minimize the length, and I saw right now, okay, if I do a 4 mod 1, I'll get a 0 because I am doing a modulo of a higher value with a smaller value. Even if it would have been a 2, I would have got a 0, and ultimately in my mind I can repeat my modulo operation only when I have some positive value. So instead of 0, I would want, okay, it is a 4 mod 1 which was actually making it as a 0. Maybe it might result in a small answer, but still I don't want to get a 0. I will get 0 in a worst possible case. So if I do a 4 mod 1, I'm getting a 0. Can I change the conditions? Which means, why? See, firstly look at the condition. Why you are getting a 0? You are getting a 0 because you are doing a modulo of a larger value with a smaller value. So there's a high chance that you will get in a modulo answer as a 0, or basically a very less value. But less value, okay, that's okay, but 0 you can get, that's a high chance. But Aryan, how high chance? Because what if a 2 would have been there? Again, you would have got a 0. What if a 3 would have been here? Then maybe you would have got a 1, which is a non-zero value. But still, if I just revert it, which means if I did a 1 modulo 4, then for sure I'll get a 1. If I do a 2 modulo 4, then for sure I'll get a 2. 3 modulo 4, then for sure I'll get a 3. Which is all just reversing it, which means smaller number modulo by a larger number will always give a smaller number, and my numbers are always more than equal to 0. So I'll get always more than 0 values, which means I'll always get a positive value. So one thing which we have seen so far is, okay, I want to do this modulo operation again and again, so as to satisfy this condition that, okay, I want more numbers to be more than 0. So I will just make sure that I am doing the modulo of a smaller value with a larger value, so that only the smaller value will come in picture as the answer, and that will for sure be positive because my inputs are for sure positive. So that is one thing which you have realized. Okay, that is great. Now let's try for this, the thing which we saw. Let's try for this specific answer. So I'll do a 1 and see, which means I'll just take every values, I'll just do a model with the smallest value possible. So let's just simply sort it down for our simplicity to view. I know one thing for sure, this is the smallest value in our answer. That's it. So I'll simply do modulo with this. I'll do a, okay, 1 mod 4. Right, 1 mod 4. I'll do a 1 mod 4. So again, all the large values I will do modulo with the smallest possible value, because I have simply sorted. So the first location I have the smallest possible value. So I'll do a 1 mod 4, which will for sure give me a 1, which is the smallest value. So you will see 1 and 4 will be deleted and then 1 will be added, and 1 is the exact same one because I am doing a smaller modulo larger value, and you remember that it is sorted. So in the end I will for sure have a larger values. So okay, and then I can start the same thing as, okay, just remove the 4 itself. Remove the 4. 1 will still be there because 1 was simply added again. Now adding in the end will not matter to us because we saw that, okay, I and j are just any indexes whatsoever. So adding anywhere in the array will not matter to us. Now that's the interesting part. Now I'll do a 3 mod 1. Again, answer will be 1. So 1 will be added and then 3 will be gone. Again, a 1 will be doing a mod 1. Okay, it's just equal value. Ultimately, both will be gone. I'll get a 0. And 0 will be the only value in the answer. And again, as soon as you get a 0, you cannot touch it because you saw you cannot perform operation on 0 itself. So as soon as you get a 0, you cannot touch it. Okay, the answer is just one element, which is a 0. Let's take the thing which we saw. Let's take the same example with the next element, 5, 5, 5 and 10. We remembered, okay, I'll do a 5 mod 10, I'll get a 5. Okay, this is gone. I'll do a 5 mod 5. Again, I'm doing with the minimum value. Right now minimum value is 5 itself. So I'll do a 5 mod 5. I'll get a 0. Okay, both are gone and I have got a 0. I cannot touch this 0 right now. Okay, 5 mod 5. Again a 0. 0. So you saw I got 2 zeros. Answer is a 2. Now, okay, 2, 3, 4. 2, 3, 4. I'll do a 2 mod 4, I'll get 2. Okay, this is gone. I'll do a 2 mod 3, I'll get 2. Okay, this is gone. And for sure, ultimately one element remaining, which is the minimum. For sure, 1 will remain for sure because minimum. So answer is 1. So maybe you might be thinking, oh, it's so easy. But you saw one thing was sketchy here, that I had so many 5s and then one of this one. You remembered our ultimate aim, maksad. Our maksad was we wanted to do modulo. We wanted to do modulo with the smallest possible value, and we wanted, okay, it's much better for us that, okay, because ultimately we remembered if the smallest possible values were actually repeating, so I had to do like division, like modulo with himself itself. So for sure I'll get a 0 with him. Here you remember, if I'm doing a modulo with him, I'll for sure get a 0. So 1 0 I got from here and 1 0 I got from here itself. So my ultimate aim right now was, okay, I'll do a modulo with the smaller value, but can't we just change the smaller value itself? Because we remembered, okay, our ultimate aim that I can do a modulo with any value. And I also thought I'm doing a modulo with the smallest possible value. Right now the smallest possible value was 5, but its count was way too much. I don't want this much count. Can I get any lesser number? Can I get a smaller value? Can I get a smaller value, but its count should be less than 5. Its count should be less than the count of 5. Can I do that? It's just as simple that if I just change the example and do a 11. So you just wanted a smaller number than 5, right? So what you would have done was just do a 5 mod 11. Again, sorry, it's 11 mod 5. Oh, Aryan, that is different what you spoke earlier. You were earlier doing a smaller value modulo with a larger value to actually get the smaller value itself. Yeah, we were doing that and we will for sure do that. But I was doing a smaller value modulo with a larger value. But now I am saying I want to reduce. I know, okay, I have 5 as a smaller value, but 5 has a very lot of count. I want some smaller value than 5 itself, which is actually having a lesser count. And so what I'll do is, okay, I'll do a modulo with 5. Now, what is the benefit of doing the modulo with the smallest number itself to any other number is that you will get a value. Okay, this result of this will be in the range of 0 to 4, which is for sure lesser than 5. So with this action, I can get a smaller value than 5. But again, I don't want to get a 0. So 0 will be discarded. I should be like my ultimate aim, goal, maqsad should be getting a value between 1 to 4, which is for sure smaller than 5. And with this one operation, let's say here I got a 1. With this one operation, I got a 1 here, right? This 5 and 11 are gone. Now comes the interesting part. Now all the other values should be doing a modulo with this 1. So I'll do a 1 mod 5. 5 will be gone. I'll do a 1 mod 5 again this 5 will be gone. I'll do a 1 mod 5 again, this 5 will be gone, and thus ultimately you will get a 1 in the as the just single value. So now you remembered, like now you just got that, okay, we have smaller values and we are doing a modulo with, okay, smaller value modulo with all other values. But then there can be a pain to us if the smaller value count is a lot. But how we can overpass this is by doing a fact, okay, 5, like smaller value, let's say name it as element, smaller value. If I do a modulo with any of the remaining elements of the array, which means any of the remaining elements of the array, and if I get the minimum value, and I just want just one occurrence, I just want any one non-zero occurrence. If I do a modulo with 5, which is the smallest value, it should be actually here. I just want any one value, because as soon as any one value will come, I will put it at the first place, and I will be doing modulo of all the other values with this smaller value, because I know its frequency is 1, because I did modulo just one times with that specific 5 mod 11. Let's say, what if Aryan, they would have multiple 11. So would you have done 5 mod 11, 5 mod? No. I just wanted one smaller value, and I wanted specifically only one smaller value. So I'll do a modulo only one time. I'll do a 5 mod 11 mod 5 only one time. So both will be gone and I'll get a 1. Now it's exactly same as the previous problem, that okay, all larger values will be doing a modulo with a smaller. Okay, 1 mod 11, I'll get a 1, remove this. 1 mod 11, 1, remove this. 1 mod 11, 1, remove this. 1 mod 5, okay, 1, remove this. 1 mod 5, okay, remove this. So with this, I just got a 1 smaller value, and voila, I'm good. But in the current example, we could not have done that, because it was a 5 and a 10. If I do a 10 mod 5, I'll get a 0. 0 is something which if occurs, I cannot change it. I cannot use it. So there's no point to generate a 0 itself. So I'll not generate a 0. At all. I'll just make sure, okay, if I can generate any other value other than 0, if I do a modulo with the smallest number, because if I do a modulo with the smallest number, for sure I'll get a value which is less than the smallest number, from 0 to smallest number minus 1. But I don't want the value to come as 0, so I'll just try for all the values with the smallest number in the entire array, and for sure if it is less, I'll keep it here. And then I know ultimately that, okay, I can do every number's modulo with him, and for sure he can handle that ultimately, and ultimately he can handle every other number. So for sure the count will be ultimately 1. If I am able to achieve any number, which is this specific number in the very beginning, answer will for sure be 1, because every number will actually be able to do a modulo with this number. But what if we are not able to achieve this? As in this current example, we were not able to achieve any small number which is non-zero. So ultimately what will happen is we will just get the count of this same elements, because we know, okay, all the remaining elements I can do the modulo with the smaller values, but now the smaller values will remain intact, right? This will remain intact. So okay, you can simply make pairs, so it will be nothing but ct by 2. As simple as that. But Aryan, what if I'm not able to make a pair? Oh yeah, let's say if we have odd number of smaller elements, then I'll just make sure one thing, okay, I can make a pair, but this cannot make a pair. So I'll just use a seal value. So I'll do a CT plus 1 by 2. Count is actually a 3. This is, see, CT plus 1 is another way of representing a seal. So if I do a CT by 2 and do a seal, it is same way I can write it as CT plus 1 by 2. It's exactly same. Cool. And that's how I can simply achieve it. So you saw that how we approached it. Firstly, you saw, okay, what is free? How? See the pattern. Firstly, we saw why is this useful? Then we saw that ultimately this was useful so that we don't want to generate a 0. Then we saw that I can use any of the INJs. Then I saw that, okay, remaining modulo value, if it is actually less, remaining modulo, if it's actually less, then I can repeat and I can reuse that value. So I ultimately wanted that, okay, this modulo result should actually be a positive value. So then I ultimately thought of, okay, if it is less, it is more, then only less value will come as an output. Then I thought, okay, yeah, that is true, but there can be an edge case. But yeah, thinking of this edge case is actually difficult. The thinking of edge case is, oh, it can actually happen that I might be able to make a smaller number, which is actually less, like whose count is actually less, because I can make a smaller number with doing a modulo with other number, which is 11 mod 5 is actually will give you a 1. So you can place a 1, and now you can use this 1 to actually pair up all the values and do a modulo with 1 itself. And ultimately get the answer. Let's see the code. It's pretty simple. So firstly, I sorted as I showed you because it's much easy to get the smaller value. Again, you can simply get the smaller value and the count of that's only required. Sorting is not at all required at all, simply. But I'll get the smaller value. Smaller value here will represent by the element EL. I want its count also, and I will just iterate on all the elements to just know, okay, what is the count of the smallest element. Now, this is the minimum value. As you thought, like as you saw above, I wanted a value, okay, you remembered, okay, 5 5 5 5 and let's say 11. So 5 is, let's say, the element right now, right? But I could have a smaller value because you saw, okay, count of this will come as 4, but maybe I am able to achieve the minimum value, which is lesser than 5 for sure, and it is not equal to minimum val, and it is not equal to 0. So if I am able to achieve this number, that's great. Answer will for sure be 1, because I can just pair up every other number with this specific first number, which is the minimum value. So I'll also make sure that, okay, can I make this minimum value or not? I'll make sure. So here I'll iterate on the entire array, and I'll just simply check, okay, if the nums of I is equal to element, then I'll simply increase the count so as to know the count of the element, which is the smallest value right now. But I'll also make sure that I will do a modulo with all the other values, which means I'm simply doing a modulo with all the other values and seeing if that modulo is non-zero, so I can update my minimum value, because you remembered minimum value should not be a 0 itself, else it will simply add to our answer. It will actually be a both to us. So I said, okay, if the nums of I mod element, if it is not equal to 0, then I can simply update my minimum value. Okay, and again, anyway you get any minimum value, you can just, you don't need this flag, don't need this also, you just wanted a flag f is equals to 1. If you get a minimum value, you are good. Answer is 1. So I just need only a flag, although I just used it in this contest, but yeah, that's not required at all. You can simply use a flag. It's flag instead. Okay, if the minimum value is actually equal to minimum, like just getting, if I'm able to get a minimum value, which is nums of I mod element, I'm good. Answer will be 1. So as soon as this is done, if I got a minimum value, because you saw minimum value by default value is element itself, which is the minimum, this element. But if I am getting any value smaller than element, and again, which is not equal to 0, answer is 1, for sure 1. And if the count itself is 1, if the count itself, as you saw here itself, 2 3 4, count itself the smallest element, this is the element, count itself is 1, for sure, then also the answer is 1. But if it is not the case, if you are not able to achieve the minimum element, which means 5 5 5 5 and 10, if you are not able to achieve the minimum element and count is itself also not 1, then whatsoever is the count, you will do a by 2. But you also thought, like, or you also saw, what if the count is odd, then you will just do a seal value. So you can just use a seal, CT plus 1 by 2, or a seal value of ct by 2, or a seal value of ct by 2. And that's how you can simply get the answer. Again, this is a O of n log n time complexity, but you can simply solve this in O of n time because you only need the smallest element and its frequency. That's it. I hope that you got it. Right, take care. Bye bye.